Okay, so in this video I just want to go over chair conformations, and right here we have a cyclohexane with two substituents. They are both wedges, and we're going to be drawing out the one with the lowest energy chair conformation. So when you have a wedge, that means it's going to be going up instead of down. When you have a dash, it's going to be going down. And that's just something that you really have to know for drawing out these chair conformations. So we have a wedge here, and we're going to want to put the bigger group on the equatorial plane. So since we want him on the equatorial plane, we're going to go ahead and put him right here. I'm sorry, we're going to put this one right here. Ignore what I just said. This guy is carbon number 2. So if we want to number them out, carbon 1, carbon 2, we're going to go ahead and put him over here. Now, the reason why this would be the lowest energy conformation is because we have the biggest group on the equatorial plane. Now, if we put him on the axial plane like this guy, that would make him more unstable. And that's not what we want right now. If we move on to the second example, we have a halogen and 3 substituents in total. So we'll go ahead and draw out the chair. So this time we have a dash instead of a wedge. Well, we still have a wedge, but we have 2 dashes this time. So we'll go ahead and draw them, and they need to be facing down. That is something that's very important. So go ahead and number them: carbon 1, carbon 2, and carbon 3. So he has to be going down like that. And since he is also a wedge and he's a chlorine, he's gonna have to be going down through here. And then here we have a dash, so he has to be facing up. Now this would not be the lowest energy conformation state, so we're gonna go ahead and draw that one out. And if you wanna figure that out, you just have to flip the ring, which basically means we're going to move each carbon over by 1. When you flip a ring, that does not change the way these guys are facing. It only just changes the plane that they're on. So if they were axial, they're going to be equatorial now. So we're going to go ahead and move him over. So carbon 1, and he has to be going down. I guess that doesn't change. And then carbon 2 be here. He needs to be going down because he's the chlorine, and on carbon 3 he's going up. So this one would be the lowest energy one because most substituents are in equatorial plane, as compared to here most substituents are in the axial plane, making it more unstable.